Hey guys, so now we want to look at some structs and how they're implemented, how do you use them, and there is another tricky thing about pointers to structs and how to access their fields. So let's dive into it. So first of all, we want to include, obviously, as always, standard input-output, and then we want to add this standard library .h to be able to use pointers, I think. Anyway, so let's define two structs, and one is very simple, is just a struct called allergies, and it has three fields in it that will hold integer for nuts, integer dairy, and integer animals. So basically, my idea is 0 is for no allergies, and 1 if someone has allergies. And then if you want to use that struct, you would have to use the full struct allergies line. So that's just a bit longer than using a single word for the type. So if you use type def struct allergies and the name you want to give it, in this case I just named it exactly the same but with the capital letter. You can leave the lowercase as well if you want. It doesn't matter. Basically, from now on, it's going to use this as our type data type, but I can also use struct allergies. Yeah, so in here you can see this. I can use this, or I can replace it with capital A allergies. Okay, and it's just a bit faster that way. In here we have a second struct called student, and as you can see I put type def before struct. So basically you can achieve this by doing this. So instead of taking type def, instead of adding a line here, we just encapsulate it with type def on that side and the name we want to give it on this side. Okay, very easy. So I gave a student a name, which is a string. Char star is a string. And then we have registered, again, the same idea. 1 is yes, 0 is no. Allergies called, and the variable here is called allergies. It can be done that way, not a problem. And then we have a struct student pointer to the next one. So I want to be able to use this structure to create a linked list, something that's stack and queue that we discussed on computer technology 2. Stack and queue, stacks and queues are basically linked lists that are being approached in a different way, but they're still linked lists. They have a field, and so in here we have a couple of fields actually, and then we have a pointer to the next structure of its own type, I suppose. Okay, let's move in here. I actually run it here, so maybe I'm gonna clear that for now because I don't want to focus on this. So in here we have, and then we want to prototype any functions that we have implemented at the end of the code in here. This guy here, it's our function that I prototyped in here. So the computer knows that it's gonna, the code, the C compiler basically knows that it's gonna appear somewhere. And then we jump into main. So we say int, that it's gonna return an integer at the very end, and we start with main, and there's no argument here. Okay, so let's create a pointer to this to a structure student, okay, and call it student list, and that's how I want to indicate that my student list starts at that point. Yeah, student list pointer will be pointing at the first item of my linked list. For now, it's empty. It points to nothing. And then we create first student, an example. And in here, for stack and queue, we have push and we have enqueue. These two functions basically create a new example, like in here, a new instance of whatever, of the stack node or queue node, and it links it in a certain way to the kind of the main stack or main queue that we have in main function. In here, I simplified it. I just create something as we go, and just in main, I create an example in here. Okay, first I declare it, and then I fill in all the fields. So name, is it registered, allergies, blah blah blah, 3 different allergies, and just 1 second. Sorry, as you can see here, use a dot if you want to go directly. So this is not a pointer. This one here is an instance of a student. It's not a pointer to it. In here we have a pointer, and then you would have to use the arrow notation like in here, but about that in a second. If it's just an instance of student, you access its fields by just using a dot notation. So you write the name of the student, in this case it's example, then you go to name field that we have in here, yeah. Then in here we go to registered field, in here we go to allergies, and in those allergies we go to nuts field, okay. So we go to this allergies field here, and then because that allergies is a struct of itself, it also can be accessed like this to the field nuts. Okay, so we access allergies and then we access nuts. In here, allergies dairy, allergies animals. We assign some numbers to it. I know it kind of doesn't make sense that the allergy has a number, but let's just assume it's fine. And then we have an example, and for now we're gonna just assign it to nothing. Null. There's no pointer, it points at nothing. Okay, and now we want to print the student, and we pass this example 1, so this guy in here, to my function print student. And what it does basically, it just prints it out, okay, one by one. And there are no pointers in here. I pass it by value, so there is nothing crazy going on in there. It's very straightforward function. So it prints it out, and then I want to assign the address of my newly created guy to my student list. And as you can see, student list itself is a pointer, so I don't need to put any star or anything in here. But in here, I had to add an ampersand because I want to take an address of my example, okay? And then the fun with pointer starts. So here we have this silly arrow notation that basically says, okay, so student list, go to whatever you're pointing at. I know you're a pointer. I know you are a pointer. So please tell me what you're pointing at. Okay. And well, not tell me in this case, kind of go to the place that you're pointing at and take the field name of that thing. Okay, you can use this notation only with structs. So if you have something that has that is created that way and has its fields, at least one field, so you can access it that way. You say, hey, I know you're pointing at some struct, go there and take name field, okay? And then assign Markubiak to it. And it's the same guy. We are pointing at this guy in here. Student list is pointing at example 1. So then if we want to go to student list arrow name, we go to this. If we write something like this, student list arrow registered, we access this. No, it doesn't matter if we want to print it or we want to input something in there. So output input is the same. So in here, we want to print after making those changes. Although I did no change to example, you can't see example here, but I was actually changing example because it's linked now. And so we want to see example, and then after we want to see star student list. So basically dereferenced student list, which should be the same. They should be two same outputs. And then at the very end, I just want to show you that you can use the arrow notation as well for printing. So if you put, I want to print a string, and that string is located in student list arrow name. So it goes to student list because it's linked, and it checks what is it pointing at, and it takes the name field from it. And that's how the arrow notation works. It only works with pointers to structures. Okay. So let's see what's gonna happen. I have it compiled, so I'm gonna just run it now. Test4 is it? Yeah, test4. So let's start from the beginning in here. Let's look at the first piece in here. This is that guy here. I assigned some values to my first example, and I printed it out. So there is Marek, there is 1, there is 0, there is 1, there is 0, there is nil, which is like null, printed out. It's fine. It's exactly as I assigned in here. So then we linked this example to student list, and then we changed that through student list. We didn't use example 1 in here, none in here. So we just went through student list, go to that first example, and then go to that field called name, and here is your and assign Marek Kubiak to it. And here you can see it actually worked. This is our first print with example 1, and here is our second print with dereferenced student list, which is exactly the same. The purpose is in here, go to example 1 and take the values from there, and in here it's exactly the same. Go to the address of example 1 and take the contents of it and pass it to this this function here. Okay, so it should look exactly the same, and it does. And in here, two last lines, we're using student list and the arrow notation to name, and it also worked. You can use print and the arrow notation as well. Okay, and in here you can see which we printed nuts. So again, in here we use arrow because this is a pointer to example 1, but in here this is not a pointer. This is just one of the fields. So to access it, you just write dot nuts. Okay, I hope it makes sense, and I'll move to the next subject in a second.